So we will solve the numericals, and here in chapter 11, problem number 11.1, it is written here: normal conversation involves sound intensities of about 3 into 10 raised to power minus 6 watt per meter square. Here intensity level is given. Normal conversation is equal to how much? 3 into 10 raised to power minus 6 watt per meter square. What is the decibel level for this intensity? Sound level or intensity level is asked. Intensity level, or it is also known as sound level. It is to be answered. What is the intensity of sound for 100 decibel? It is part number 1 and here part number 2. If sound level is equal to 100 decibel, then intensity is to be found. फिर हमने इंटेंसिटी फाइंड करनी है. So solution part 1, for solution part 1 we know the formula. Intensity level is equal to 10 log of I by I naught in decibel. So putting the values, we get intensity level is equal to 10 into log of, what is the value of I? 3 into 10 raised to power minus 6. What is the value of I naught? You know it. You will memorize it. The least level of intensity is 10 raised to power minus 12. Keep it memorized. So we get 10 log of 3 into 10 raised to power minus 6 plus 12. This is transferred in numerator. It was in denominator. When you transfer the powers in numerator, it becomes positive. So we get is equal to 10 into log of 3 into 10 raised to power plus 6. Now apply law of log here. We get is equal to 10 into log of 3 plus log of 10 power 6. We get it as 10 into, you will calculate it in calculator. What's the value of log of 3? So it is 0.48 plus. Here also you will apply law of log. 6 will come as a coefficient over here. So we will get 6 log of 10. And what is log of 10? Log of 10 is calculated in calculator and it comes 1. So you write is equal to 10 into 0.48 plus 6 into log of 10 is 1. Now what? 6 ones are 6, add in it, you get 10 into 6.48, and so multiply it, you will get 64.8 decibel answer. So it is the sound level or intensity level. Now in its second part, again in part number 2, the sound level is given, intensity is asked. So again the formula is sound level is equal to, wait a minute, sound level is equal to 10 into log of I by I naught. And here, what is sound level? Sound level is given 100, put the values, we get is equal to 10 into log of I divided by, what is the value of I naught? You will keep it memorized. It is 1 into 10 raised to power minus 12. Now, you just divide it by 10 on both sides. To shorten it, we get 10 is equal to log of I minus log of 10 is power minus 12. How? Here you applied law of log. Log of A divided by B is equal to log of A minus log of B. Application of law of log. So we get 10 is equal to log of I minus, and this will again, third law of log, power comes as a coefficient, minus 12 log of 10. So we got 10 is equal to log of I minus minus plus 12 into log of 10 is 1. We got 10 is equal to log of I plus 12. This positive 12 will shift on left hand side, and we will get 10 minus 12 is equal to log of I. So we can write, if you exchange left hand side with right hand side, no change of sign. So you can write log of I is equal to minus 2, and I is equal to anti-log of minus 2. And what is anti-log of minus 2? You will write 10 is power minus 12. Anti-log of minus 2 is 10 is power minus 2, and it is 1 by 10 is power 2. It is 1 by 100. It is 0.01 watt per meter square. So this is the answer. Alright. Okay, in question number 11.2, numerical 11.2, what is written? It usually comes in boards exams. If at Anarkali Bazaar, Lahore, intensity level of sound is 80 decibel, sound intensity level is equal to 80 decibel given. What will be the intensity of sound there? and I is equal to question mark. Again, like numerical number 1 part number 2. Again, in the same way, you know the formula. Sound level is equal to 10 into log of I by I naught. Here sound level, put the values. Sound level is 80 is equal to 10 into log of I. This is to be calculated, and I naught you will keep memorized 1 into 10 raised to power minus 12. Here 0 is cancelled by this 0. We got 8 is equal to log of I. Again, log of A divided by B is equal to log of A minus log of B. Second law of log. Okay, we get log of I minus log of 10 raised to power minus 12. Here you get 8 is equal to log of I minus into, again, third law of log. Power becomes coefficient of this log, minus 12 into log of 10. So you got 8 is equal to log of I plus 12 into log of 10 is 1. So 8, this 12, ones are 12, it will be shifted on left hand side, and we will get 8 minus 12 is equal to log of I, or we get minus 4 is equal to log of I. So we have got log of I is equal to minus 4, or I is equal to, this log will shift, we will move it on the right hand side and it will become anti-log of minus 4. And what is anti-log of minus 4? It is 10 raised to power minus 4, mean is equal to 1 by 10 raised to power 4. It is equal to 1 by 1, 2, 3, 4, and it is equal to 0.0001. Okay, you got the point? So we have its answer as 0.0001 watt per meter square. You can leave it as it is equal to 10 raised to power minus 4 watt per meter square. Both these are correct, but it's better if you compare it with your answers in the book. Now in 11.2, what is written? It is important question, and usually it comes in boards papers. In Anarkali, Lahore, intensity level of sound is 80 decibel. Means sound level is equal to 80 decibel. What is intensity of sound? What will be the intensity of sound there? Intensity of sound I is equal to question mark. Again, the same formula, you know, sound level is equal to 10 times log of I by I naught. So putting the values, we get 80 is equal to 10 into log of I by I naught. What is value of I naught? Keep it memorized. I naught is equal to 1 into 10 raised to power minus 12. So we get here 0 is cancelled with this 0 on left hand side. We got 8 is equal to log of I minus log of 10 raised to power minus 12. Log of A divided by B is equal to log of A minus log of B. So leave this one, and we got log of I minus log of this denominator, log of 10 is power minus 12. Now solving it, 8 is equal to log of I minus into, again applying the law of log, this power comes here as a coefficient and we get log of 10. So 8 is equal to log of I plus 12 into, what is the value of log of 10? It is 1. So 12 ones are 12. You transfer this 12, shift it on left hand side, we get 8 minus 12 is equal to log of I. So we get log of I is equal to minus 4. Now solving it, what we get? Log of I is equal to minus 4. I is equal to NT log of minus 4. And what is NT log of minus 4? 10 is power minus 4. You write it as 10 raised power whatever the anti-log is to be formed. So we got I is equal to watt per meter square. Now what you will do is, now we will solve numerical number 11 point. Okay, in problem number 11.3, at a particular temperature the speed of sound in air is 330 meter per second. Speed of sound is 330 meter per second. If the wavelength of note is 5 centimeter, wavelength of this sound is 5 centimeter, convert it in meter, we get 5 into 10 is power minus 2 meter, or you may say is equal to 5 divided by 100. You can write 10 is power 2, or is equal to 5 by 100, or is equal to 0.05 meter. Now written, calculate the frequency of the sound wave. Is this frequency in audible range of human ear? So we have to calculate frequency, number 1, and number 2, does it lie in audible frequency range, that is between 20 Hertz to 20,000 Hertz. You have to answer this also. So solution for part number 1, we know V is equal to F lambda, and we have to calculate this frequency. Lambda is multiplied on right hand side, we will shift it on left hand side, so we get F is equal to V by lambda. We can say F is equal to, what is velocity? Velocity is 330 divided by, what is the value of lambda? 0.05. So calculate it, and on calculator it will come 6.6 into 6.6 into 10 is power 3 Hertz. And as you see, this 6.6 into 10 is power 3 Hertz lies in this range. So for answer number 2, you will write yes, this frequency lies in AFR. As you see, what is this? 6.6 into 10 is power 3 means 6.6. Answered, you got 6600. 6600. It lies here somewhere. 6000. It lies here somewhere in this range. So its second answer is yes, this frequency lies in AFR. Now we will come towards .4. So here in 11.4, a doctor counts 72 heartbeats in 1 minute. Heartbeats. 72 in 1 minute. This means 72 in 60 seconds. Then calculate its frequency and period. Period means time period. So here we will solve it. How? Frequency is equal to vibrations divided by time in seconds. Here vibrations are 72 and time is 60 seconds. So we got on calculator, you will calculate it, and we get 1.2. 72 divided by 60, we get 1.2 hertz. Hertz is the unit of frequency. Now for time period, we have another formula. Part number 2. Time period is reciprocal of frequency. These are the formulas. Okay. So we write 1 divided by 1.2. Again, use a calculator and you will calculate it, and it will come 0.83 second. Unit for time period or just period, unit for period is seconds also. Okay, now we will come towards next problem. So in 11.5, marine service ship sends sound wave straight to the sea bed. तो एक शिप है, मैरीन शिप, वो क्या करती है, साउंड वेव्स सी बेड की तरफ सेंड करती है. वो नीचे कहीं टकराती है, तो टकराने के बाद वो बाउंस बैक होके वापस आती है और इधर रिसीव होती है. नीचे जाने का डिस्टेंस d, वापस ऊपर आने का डिस्टेंस d. तो टोटल डिस्टेंस कितना हो गया, s इज इक्वल टू 2d. और टाइम कितना लगता है उसने बताया है. It receives an echo 1.5 seconds later. 1.5 seconds. यानी 1.5 सेकेंड में जाती भी है और वापस भी आती है ये साउंड वेव्स. तो उसने पूछा है कि इसकी सी की डेप्थ बताएं. हाउ मच इज डी. डी आपने कैलकुलेट करना है. जबकि उसने बता दिया है velocity of sound in sea water is V is equal to 1500 मीटर पर सेकेंड. ये वेलोसिटी बता दी है उसने. ठीक है, दिस इज द डेटा गिवन. नाउ वी विल सॉल्व इट. सॉल्यूशन क्या होगा? सॉल्यूशन के लिए वी नो द फार्मूला S is equal to VT. Here S is 2D is equal to velocity is 1500 into time is 1.5 second. So D is equal to 1500 into 1.5 divided by 2. Now calculate it on calculator and we get as 1125 meter. So the depth of this seabed is 1125 meter. Very simple. Sound waves are thrown towards the bed. Sound waves फेंकी गई हैं सूरज के समुंदर के नीचे जो लेवल है, ग्राउंड लेवल उसका, जमीन है जो समुंदर के अंदर उसके बेड तक, वो वहां टकरा के वापस आती हैं, जो इको 1.5 सेकंड के बाद सुनाई देती है. और हमने देखा डिस्टेंस क्या है, वेव्स जाती हैं और जाके फिर वापस आती हैं D plus D. S is equal to 2D. वेलोसिटी ऑफ साउंड इन सी वाटर कितनी है? 1500 मीटर पर सेकेंड. तो कह रहा है डेप्थ इसकी फाइंड करें, तो सिंगल D हमने फाइंड करना है. वी हैव सिंपल फार्मूला S is equal to VT. Put the values and calculate it for D, the depth 1125 meter. Now for 11.6, here 11.6. In 11.6 a student clapped his hands near a cliff. यहाँ कोई चट्टान है, इसके सामने ये स्टूडेंट यहाँ खड़ा है. क्लैप करता है, तो इसकी क्लैप की आवाज जाती है, टकराने के बाद वापस आती है. तो टाइम है गिवन है 5 सेकेंड. आफ्टर 5 सेकेंड, 5 सेकेंड के बाद ये आवाज सुनता है. अगेन द सेम केस, जाने का टाइम, डिस्टेंस कवर्ड इज D, टकरा के वापस आने का डिस्टेंस D. टोटल S is equal to D plus D means S is equal to 2D. And time of echo, echo means साउंड गया, टकरा के वापस आया, तो कितना टाइम हो गया? 5 सेकेंड्स. वो पूछ रहे हैं कि क्लिफ उससे कितने डिस्टेंस पे है. वहां खड़े खड़े वो कैलकुलेटर पे बता देगा कि जनाब कितने डिस्टेंस पे वो क्लिफ, वो चट्टान कितने डिस्टेंस पे है. अगेन, एंड वेलोसिटी इज गिवन एज, वेलोसिटी ऑफ साउंड इज गिवन 346 मीटर, 346 meter per second. Again the same case, how you will solve it? How? Using formula S is equal to VT, same formula as you memorized in 9th class. Put the values. 2D is equal to, velocity of sound is 346, time is 5, so distance is 346 into 5 divided by 2. Use the calculator and you get how much value? 865. So the cliff is 865 meters away. क्या है? A student stands here, he claps, and then hear the echo after 5 seconds. The sound went and covered D distance. hit the cliff, came back, covered the d distance. Total distance s is equal to 2d, and time is 5 seconds. So we have to calculate the distance of this cliff, that is 1d. So d is to be calculated and velocity is given 346 meter per second. Using the formula s is equal to vt, put the values and we got d is equal to 865 meter. Now we will come towards 11.7. 11.7. Again in 11.7, a ship. Here is a ship. Send the ultrasound signals up to the seabed. समुंदर की जो डेप्थ है, वहाँ जो ज़मीन है वहाँ तक वो साउंड के सिग्नल भेज रही है. अगेन डिस्टेंस कवर इज d. साउंड टकरा के बाउंसेस बैक एंड रीचेस बैक हियर. अगेन इट कवर्स डिस्टेंस d. So the total distance is d plus d is equal to 2d. Echo is heard after what time and is detected after 3.42 seconds. Time of detection is 3.42 seconds. And what is the velocity of this ultrasound? And that is given 1531 meter per second. Again the same case, depth is to be calculated. कि नीचे गहराई कितनी है समंदर की उस जगह पे. तो we use the formula s is equal to vt. Put the values. 2d is equal to 1531 into 3.42. So d is equal to 1531 into 3.42 whole divided by 2. And you will calculate it and you will get its answer as 2618 meter. This is the depth of this seabed. एक शिप जा रहा है और उन्होंने कहा चलो जी हम समुंदर देखते हैं कितना गहराई पे है. इस जगह पे हर जगह गहराइयाँ डिफरेंट है क्योंकि अंदर भी पहाड़ियाँ और खाइयाँ और बहुत कुछ होता है. तो आप वो देखना चाहते हैं तो उसके लिए अल्ट्रासाउंड वेव्स उन्होंने सेंड की हैं. वो टकरा के तो वापस आई हैं तो टाइम लगा 3.42 सेकेंड. डी डिस्टेंस जाने का और डी वापस आने का. तो टोटल डिस्टेंस कवर्ड इज s इज इक्वल टू 2d. और वेलोसिटी वहाँ साउंड वेव्स की वेलोसिटी मीटर पे आ रही होती है कि भाई कितनी. सोनार एक इंस्ट्रूमेंट है, उसकी मदद से ये साउंड वेव्स को नीचे फेंका जाता है और वो टकरा के वापस आती हैं और बताती हैं कि जनाब नीचे सरफेस जो नीचे है, सॉरी सरफेस नहीं बल्कि सी बेड कितने डिस्टेंस पे है. तो यूज द सिंपल फार्मूला s is equal to vt. Put the values and we get answer as d is equal to 2618 meter. ये उस खास जगह पे गहराई है समुंदर की 2618 meter. Now we will come towards numerical 11.8. Okay, in 11.8 highest frequency human ear can hear is 20,000 hertz. And lowest frequency we can hear is of 20 Hertz. In this numerical, he's saying what is the wavelength of sound in air at this frequency. Wavelength find करनी है यहाँ at 20 डिग्री सेंटीग्रेड. कोई ज़रूरत नहीं है वैसे कंफ्यूज करने के लिए. हाँ जी. What is the wavelength of lowest sound? और इसका भी वेवलेंथ आपने फाइंड करना है. वेलोसिटी दी हुई है. Assume velocity is 343 मीटर पर सेकेंड. 343 मीटर पर सेकेंड. ये न्यूमेरिकल इस तरह करेंगे तो बहुत आसान है. अगर ई को फॉलो करेंगे तो वो कहीं लिखता है लैम्डा एल, लैम्डा एम, लैम्डा एफ एल, एफ एम, वो वैसे कंफ्यूज कर देता है. ठीक है, तो आपने सिंपली क्या फार्मूला इस्तेमाल करना है. v इज इक्वल टू एफ लैम्डा. इसका लिख दें ये पार्ट 1 है और ये पार्ट 2 है along with data. यहाँ v इज इक्वल टू एफ लैम्डा. here also we will use the formula v is equal to f lambda. ये बड़ा इजी हो जाता है इस तरह. अगर वो लिखने जाओगे ना लैम्डा एफ मैक्सिमम, लैम्डा मैक्सिमम, एफ लोएस्ट एफ एल, लैम्डा एल, वो लिखें तो वो बहुत कंफ्यूज करेगा. आप सिर्फ फार्मूला है v इज इक्वल टू एफ लैम्डा. हाँ जी. वेवलेंथ फाइंड करनी है तो आपको पता है कि क्या पुट द वैल्यूज 343 इज इक्वल टू what is the frequency 20,000 into lambda. So we got lambda is equal to 343 divided by 20,000. तो ये आप कैलकुलेट कर लेंगे कैलकुलेटर पे. तो जनाब इसकी पहली फ्रीक्वेंसी जो है वो कितनी आती है. कैलकुलेटर पे आप देख लेंगे 1.7 इंटू 10 इज पावर माइनस 2. ठीक है, 1.7 इंटू 10 इज पावर माइनस 2. इसे जब कैलकुलेट करेंगे तो ये फ्रिक्वेंसी आ गई मीटर में. इसी तरह ये सेम फार्मूला 343 इज इक्वल टू एफ कितना है यहाँ 20 इंटू लैम्डा. दिस विल बी डिवाइडेड लैम्डा. इसका लोएस्ट का लैम्डा कैलकुलेटर पे आप कैलकुलेट करेंगे तो ये आ जाएगा 17.2 मीटर. बस ये सो सिंपल न्यूमेरिकल है. इसमें सॉल्व करने के लिए आप क्या कर रहे हैं v इज इक्वल टू एफ लैम्डा फार्मूला यूज किया. हाँ, अगर आप लिखना चाहते हैं तो आप लिख सकते हैं हाईएस्ट फ्रीक्वेंसी के लिए v f maximum lambda maximum. Here then you will write f maximum lambda maximum. ठीक है ये. और यहाँ क्या है f lowest lambda lowest, f lowest lambda lowest, lowest, and here you write it in this way. तो ये कोई ज़रूरी नहीं है, लेकिन एंड पे जब आप पहुंचे तो मैक्सिमम वाले में mm लगा दें और लोएस्ट वाले में l लगा दें. अंडरस्टैंड. नाउ वी विल कम टुवर्ड्स 11 point. Now in 11.9 a sound wave has a frequency of 2 kilohertz converted in standard form 2000 hertz. Wavelength is lambda is equal to 35 centimeter is equal to 35 centimean divided by 100. We got 0.35 meter. Whenever frequency and lambda is given, whether it is asked or not, you just calculate V is equal to F lambda. So frequency is 2000 into wavelength is 0.35 meter. And what the velocity we got, you calculate it, and it comes 700 meter per second. Now in the question it is asked, how long will it take to travel 1.5 meter? If distance is 1.5 kilometer, convert it in standard form, 1.5 into 1000 meter. It comes 1500 meter. How long will it take? Velocity is this. Velocity is equal to 700 meter per second. So S is equal to Vt is the formula you will use. Here we will get T is equal to S divided by V. And what is S? 1500 divided by V is 700. So the time comes 2.1 seconds. Got the point? फ्रीक्वेंसी दी है साउंड की, वेवलेंथ भी दी है, उसको स्टैंडर्ड फॉर्म्स में लाना ये प्रॉब्लम थी बेसिकली. और v इज इक्वल टू एफ लैम्डा से हमने क्या किया, v इज इक्वल टू एफ लैम्डा से वेलोसिटी फाइंड कर ली. उसने कहा ये साउंड 1.5 किलोमीटर डिस्टेंस कितने टाइम में कवर करेगा. वी हैव द फॉर्मूला s इज इक्वल टू vt. पुट द वैल्यू, चेंज द फॉर्म ऑफ द फॉर्मूला. इसको डिराइव करने टाइम के लिए डिराइव किया तो t इज इक्वल टू s बाय वेलोसिटी. पुट द वैल्यूज and we got time 2.1 second. There the numericals finishes.